Microservices architecture. Microservices architecture is a way of designing software systems as a collection of small, independent services that communicate with each other. Each service focuses on a specific business function and can be developed, deployed, and scaled independently. Key features of microservices. Independence. Each service can be developed, deployed, and scaled independently. Decentralization. Different teams can work on different services, allowing for greater flexibility and innovation. Resilience. Failure in one service doesn't necessarily bring down the entire system. Technology diversity. Teams can use different technologies and programming languages for different services. Monolithic architecture. Monolithic architecture is a traditional approach where an application is designed as a single, cohesive unit. All components and functionalities are tightly integrated and run as a single service. Key features of monolithic. Single code base. Everything is in one code base and usually runs as a single process. Tight coupling. All components are interconnected, making changes or scaling challenging. Centralized management. One team often manages the entire application. Differences between microservices and monolithic architectures. 1. Size and scope. Monolithic, large, unified code base. Microservices, small, focused services. 2. Development and deployment. Monolithic, difficult to make changes and deploy updates. The whole application needs to be redeployed. Microservices, easier to update and deploy individual services without affecting the entire system. 3. Scalability. Scaling requires duplicating the whole application, which can be inefficient. Microservices, individual services can be scaled independently based on demand. 4. Flexibility. Monolithic. Harder to adopt new technologies or frameworks. Microservices allows for technology diversity. Different services can use different technologies. 5. Fault isolation. Monolithic. A failure in one part can affect the whole application. Microservices. Failures are contained within individual services, improving overall system resilience. Microservices orchestration. Orchestration, in the context of services, involves managing the deployment, scaling, and operation of microservices. It ensures that all the services work together seamlessly. Tools like Kubernetes are commonly used for orchestration. Key concepts: service discovery, automatically finding the network locations of microservices. Load balancing, distributing network traffic across multiple services to ensure no single service is overwhelmed. Scaling, automatically adjusting the number of instances of a service based on demand. Self-healing, automatically detecting and replacing failed instances of services. Other related concepts. 1. API gateway acts as a single entry point for all clients, handling requests and routing them to the appropriate services. It can also manage security, back rate limiting, and other cross-cutting concerns. 2. Service mesh, a dedicated infrastructure layer that controls service-to-service communication, ensuring reliable and secure communication between microservices. Examples include Istio and Linkerd. 3. Containerization, packaging a microservice along with its dependencies and runtime environment into a container, e.g. Docker, to ensure consistent deployment across different environments. 4. Continuous integration, continuous deployment, CD, automating the process of integrating code changes, testing them, and deploying them to production, which is essential for managing numerous microservices. 5. Observability, monitoring the health and performance of microservices, including logging, tracing, and metrics, to quickly identify and resolve issues. Tools like Prometheus, Grafana, and Jaeger are used for observability. Summary. Microservices architecture breaks down a large application into smaller, independent services, providing flexibility, scalability, and resilience. In contrast, monolithic architecture is a single unified application that can be harder to manage and scale. Orchestration tools help manage microservices efficiently, ensuring they work together seamlessly. Concepts like API gateways, service meshes, containerization, CI/CD, and observability are essential for implementing and managing microservices effectively.